Hello and welcome back to e-sipnayan. For today's video, we are going to discuss angles in rectangular coordinate system. But before we proceed, do not forget to hit like and subscribe so that you'll get notified once we upload new video. For this video, we are going to achieve the following learning objectives. First, we should be able to define angle and its part. Next, identify the kinds of angles, then draw positive and negative angles, and lastly, identify where the terminal side of an angle in standard position lies. Let's first recall what an angle is. In geometry, an angle is defined as a union of two rays intersecting at a common endpoint. So basically, an angle consists of these parts. First is the side, and the sides are the two rays intersecting. Then we also have the vertex, which is the common endpoint of the two rays. Shown here on the left is an illustration of an angle with its corresponding part. So the two sides or the two rays are more particularly called as the initial side and the terminal side. They share a common endpoint which is called the vertex. Now the initial side is the starting ray of the angle, and the terminal side obviously is the ending ray where the angle stops rotating at a certain angle. Aside from that, here are more information about angles. First, it is measured using a protractor, and the symbol that we are going to use for angles is this one, which is called or read as theta. Meanwhile, the unit of measurement for angles are in terms of degrees and radians. You are more familiar with degrees, but with radians, we are going to define it sometime later on when we discuss the unit circle. Before moving further, let's recall the types of angles that you learned in junior high math. The first type of angle you should be familiar with at this point is the acute angle. Acute angle is defined as an angle measure greater than 0 but less than 90 degrees. Or in terms of inequalities, it can be written as theta, or the angle is greater than 0 but less than 90 degrees. In a Cartesian plane, recall that this portion is 0 degrees, then rotating counterclockwise will give you at this point 90 degrees, then 180 degrees, to 270 degrees until we reach 360 degrees, which is one full rotation. So an acute angle or the terminal side of an acute angle will always lie on the first quadrant. So the initial side will always be here at the positive x-axis. This will be our initial side. If it is an acute angle, the terminal side will only be inside the first quadrant, and it should not exceed the positive y-axis. So say for example, the terminal side of the acute angle that we're going to draw is somewhere here. Let's say this is 45 degrees. So this is the terminal side of an acute angle. Moving on, we also have the obtuse angle, whose angle measure is greater than 90 but less than 180 degrees. Or in terms of inequalities, theta is greater than 90 but less than 180. So the terminal side of all obtuse angle will always lie on the second quadrant. So again, all initial side will always be at the positive x-axis. So if we have an obtuse angle, its angle measurement should be in between 90 to 180 degrees. Therefore, the terminal side may lie or will always lie on the second quadrant. So say for example, we have 100 degrees. So let's say theta is 100 degrees. This is an obtuse angle, and its terminal side will fall on the second quadrant. We also have a straight angle, and it is an angle measuring exactly at 180 degrees. Therefore, theta is equal to 180 degrees. Now, the graph of a straight angle is a straight line. Obviously, that's why it's called straight angle. So the initial side of a straight angle will still be the positive x-axis. Meanwhile, its terminal side, if you rotate or if you measure 180 degrees using a protractor, will end here on the negative x-axis, which is also the terminal side. Aside from that, you're also familiar with a right angle, which is an angle measuring exactly 90 degrees. So the initial side of a right angle will always be, again, just like all angles, on the positive x-axis, and the terminal side will be along the positive y-axis. So if it is a right angle, then it contains a 90-degree angle. We also have the so-called reflex angle, and reflex angle is an angle whose measure is greater than 180 but less than 360 degrees. Now, in terms of inequality symbols, theta should be greater than 180 degrees, but less than 360 degrees. So the initial side again of a reflex angle is on the positive x-axis, initial side, whereas its terminal side can lie somewhere here on the quadrant 3 or the quadrant 4. So say for example, we'll be having 200 degrees of angle measurement. So starting from the initial side, we're going to rotate theta as 200 degrees. Therefore, the terminal side will lie on the third quadrant. So a reflex angle is somehow greater in scope because the terminal side may lie on the third or the fourth quadrant. And lastly, you should also be familiar with an angle which is called a full rotation. So a full rotation angle is also called a revolution. It is an angle measurement exactly equal to 360 degrees. When you draw the angle, it will look like exactly a circle. So theta is equal to 360 degrees. And the terminal side will lie on the positive x-axis because it will go one full rotation. So the initial side will be on the positive x-axis, and the terminal side, if we rotate the angle 360 degrees, which is the value of theta, then the terminal side will also be the same as the initial side. And those are the types of angles you need to be familiar with before we start discussing angles in the context of trigonometry. Lastly, we also have the quadrantal angle. And quadrantal angle is an angle in standard position that has a terminal side coinciding with any of the axes, x or y axis. So the x-axis is this, the horizontal line. This is the positive x-axis. This is the negative x-axis. We also have the positive y-axis. And lastly, the negative y-axis. So an angle will be considered as a quadrantal angle if its terminal side will lie on any of the positive, negative, x and y axes. So special types of angles are called quadrantal angles, and some examples are 90 degrees, 180 degrees, 270 degrees, and so on. Just as long as the terminal side will lie either positive x or y axis or negative x or y axis. Let's now discuss an angle in standard position. All of the angles that we are going to discuss for trigonometry will always be an angle in standard position. So what is an angle in standard position, which was also mentioned a while ago on the definition of quadrantal angle? Let us first recall the rectangular coordinate system. It is the intersection of the x and y axis. The horizontal line is the x-axis. The vertical line is the y-axis. The intersection is the origin. The first quadrant will have the signs of the x and y coordinates as both positive. For the second quadrant, the x coordinate is negative, y coordinate is positive. For the third quadrant, both x and y coordinates are negative. And lastly, for the fourth quadrant, the x coordinate is negative while y coordinate is positive. Now, what do we mean by an angle in standard position? It is an angle where the initial side lies at the positive x-axis and its vertex lies at the origin. So it's any kind of angle you can plot on a rectangular coordinate system, and the initial side will always be on the positive x-axis. Then the vertex should be at the origin. The terminal side may lie anywhere along the quadrant, just as long as the initial side is found at the positive x-axis and the vertex is at the origin, just like this illustration. What are some examples of angles in standard position? I have here two. This one is an example of an obtuse angle in standard position because the initial side is at the positive x-axis and the terminal side is somewhere along our rectangular coordinate system. But what's most important here is that we take note that the origin should also be the vertex. So this is an example of an angle in standard position. The same case here, this is a reflex angle. The initial side is found on the positive x-axis and the vertex is at the origin. Therefore, this is an angle in standard position. Now, what are non-examples of angle in standard position? This one, because the initial side, if you notice, the initial side is here on the negative x-axis instead. Therefore, this is not an angle in standard position. Meanwhile, for this example, The initial side can be found here on the negative y-axis. Therefore, it does not satisfy the characteristic of an angle in standard position. Let's now discuss how to draw an angle. So basically, in junior high school, you use protractor to measure and draw angles. And the unit of measurement you're most familiar with is degrees, and the symbol is this one. To draw angles, we need first to be familiar with the kinds of angles according to sine. And since we are talking about sines, we know that the angles that we are going to talk about here are the positive and negative angles. Now, let's first define what a positive angle is. It is an angle in standard position, this one is very important, whose terminal side is drawn using counterclockwise direction. Now, a positive angle will be considered positive if the direction in drawing the terminal side is in counterclockwise direction, just like this one. We have here positive 120 degrees because the initial side is found on the positive x-axis, therefore an angle in standard position, and the terminal side is plotted using the direction counterclockwise. Meanwhile, an angle is considered to be negative if it is an angle in standard position, but the terminal side is drawn using the clockwise direction. Example here is negative 80 degrees. The initial side of this angle is found on the positive x-axis, therefore an angle in standard position, but in plotting or drawing the terminal side, the direction of the rotation is now a clockwise direction. That's why it will be considered as a negative angle. So to compare positive and negative angle, we just need to take note of the direction of the rotation. So if the direction is counterclockwise, we can generate positive angle. If the direction is clockwise, then we can generate a negative angle. So it's very important that when you draw an angle, you're going to use arrowheads to designate the direction of the rotation. Let's now try to draw angles in standard position and identify where the terminal side lies. We have here the first example, 26 degrees. This is a positive angle. Therefore, the direction should be counterclockwise. Now, it's very important that we become familiar with the angle measurements on a regular Cartesian plane. So, the starting point is here at the positive x-axis, and that will be 0 degrees. Then, here is 90 degrees. A straight line is 180 degrees. This one will be measuring 270 degrees. And when it goes back to the positive x-axis, this can also be 360 degrees. Now, 26 degrees is an acute angle, therefore it should be lying on the first quadrant, and we are just going to simply estimate when drawing it. So this is 90 degrees, somewhere in the middle is 45 degrees, so maybe 26 degrees will be somewhere here. So how are we going to properly draw 26 degrees? Of course, let me highlight the initial side. It will be on the positive x-axis. And then for the terminal side, it's already here. Somehow I highlighted because I use a different color of pen. This is our terminal side. And of course, since we are very particular in terms of direction, we're going to use an arrowhead starting from the initial side, going counterclockwise, pointing to the terminal side of 26 degrees. Then we can use the symbol theta equals the given angle, which is 26 degrees. So this is now the graph or the drawing of an angle whose measure is 26 degrees. Now we need to identify where the terminal side lies. And obviously, the terminal side here falls on quadrant 1 or the first quadrant. Moving on to another example, we have 130 degrees. Obviously, this is an obtuse angle. Again, since it is a positive angle, the movement would be counterclockwise. So again, let's label the degrees on a Cartesian plane. This is 0, 90, 180, 270, and back to 360 degrees. So the initial side will be here at the positive x-axis because this is an angle in standard position, whereas the terminal side will lie somewhere here on the second quadrant because it is an obtuse angle, and it follows that 130 degrees should be in between 90 degrees and 180 degrees. So let's try to estimate the terminal side of 130 degrees. If this is 90 degrees, 100 degrees is somewhere here. So let's try to estimate 130 degrees as somewhere here. This is now our terminal side. Now to be more specific in terms of direction, we are going to draw an arrowhead starting again from the initial side, then pointing to the terminal side. And we can label this as theta equals 130 degrees. Now it is very noticeable where the terminal side of 130 degrees lies, and it is on the second quadrant. Let's now try to draw 200 degrees. Again, 0 degrees is here, 90, 180, 270, and 360 degrees. The initial side, again, will still be on our positive x-axis. And then 200 degrees is somehow already greater than 180 degrees, so it will be considered as a reflex angle. So the terminal side may lie on the third or fourth quadrant. Now to estimate where 200 degrees lie, we need to check, of course, the values of the quadrantal angles. So here is 180 degrees. This is 270. Obviously, 200 degrees will fall somewhere in between. So if this is 180 degrees, let's try to estimate, add 20 more degrees to get 200 degrees. Therefore, this will be our terminal side. Again, to be more specific, this is a positive angle. That's why the movement in drawing the terminal side is counterclockwise. Starting from the initial side, again, to highlight, use arrowheads pointing to the terminal side of our estimate drawing. And we can label this one as theta equals 200 degrees. And now it's very obvious where the terminal side of 200 degrees lie, and that is here on quadrant 3. Lastly, we have another positive angle, so our movement again later would be counterclockwise. Then let us label the angles in the rectangular coordinate system so that we can easily see the angle measurements. Now, the initial side will still be on the positive x-axis. So this is the initial side. Then the terminal side is going to be either on the third or fourth quadrant because 300 degrees is a reflex angle. So let's try to look at the quadrantal angles. So 300 degrees should fall somewhere in between 270 and 360. So from 270, we just need to add 30 degrees, which is estimated somehow at this angle. So let's say from the initial side going to this terminal side, that is the angle measurement of 300 degrees. Let me just label this again as the terminal side. And then it's now very obvious that the terminal side lies on the fourth quadrant. And that is how you draw positive angles. How about if we have negative angles? Now, since we defined a while ago negative angles as angles whose direction in graphing the terminal side is clockwise, the measurement of angles to be plotted in the rectangular coordinate system will also reverse. So, obviously, since we are talking about angles in standard position, 0 degrees will always still be here on the positive x-axis. Then, if the movement is clockwise, because it is a negative angle, negative 90 degrees will be here on the negative y-axis. Then, negative 180 degrees will be here on the negative x-axis. Then, negative 270 degrees will be placed here on the positive y-axis. Then, back to negative 360 degrees on the positive x-axis. So, basically, if the angle you're going to draw is negative, the positions of 90 and 270 degrees will be interchanged, and obviously, all angle measurements will become negative. So, if we want to plot negative 26 degrees, obviously, it is a measurement between 0 and negative 90. So, negative 26 will fall somewhere here. Just an estimation. This is still our initial side. Then, we are going to rotate 26 degrees to the right because it's a clockwise direction. So, we can label this as theta equals negative 26 degrees. This will now be our terminal side. And the terminal side will be here on the fourth quadrant. So, a while ago, when we graphed 26 or positive 26 degrees, it is on the first quadrant. If it is negative acute angle, it will now be found on the fourth quadrant because the direction reversed. What about negative 130 degrees? Again, let us highlight that the rotation that we are going to make here is clockwise. Then this is again 0 degrees, negative 90 degrees, negative 180, negative 270, and negative 360 degrees. So negative 130 degrees will be somewhere in between negative 90 and negative 180. Again, just a rough estimation of the angle since I don't have a protractor. So from the initial side, we are going to move clockwise until we construct an angle estimate of negative 130 degrees. So this theta now will be equal to negative 130 degrees. And the terminal side, if you notice, lies on this time the third quadrant. So if it is a negative obtuse angle instead of being found on the second quadrant when it's positive, it will now be found on the third quadrant. What if we have negative 200 degrees? Again, this is in clockwise direction. So this is 0 degrees, negative 90 degrees, negative 180 degrees, and negative 270 degrees. So our initial side will still be on the positive x-axis. This is an example of a reflex angle which is negative. So again, we need to estimate where are we going to find 200 degrees. So it is obviously in between negative 180 and negative 270. So let's just add the negative 20 more degrees to negative 180 to form negative 200 degrees. So from the initial side, the movement now is clockwise, going to the terminal side of the angle we estimated. So this is the terminal side, and the angle that we plotted is negative 200 degrees. Therefore, the terminal side lies on the second quadrant. And lastly, we have negative 300 degrees, and this is again in a clockwise direction because it is negative. So let us again label the rectangular coordinate system. Then the initial side will still be plotted here on the positive x-axis. Negative 300 degrees should lie in between negative 270 and negative 360 degrees. So somewhere here, just an estimate again. Then draw an arrowhead from the initial side, showcasing that we are rotating clockwise until the terminal side of the angle we estimated as this is negative 300 degrees. And notice that the terminal side will now lie on the first quadrant. And that is how you draw positive and negative angles. Now the question is, since we only discussed kinds of angles until full rotation or 360 degrees, do you think an angle can exceed 360 degrees? The answer is already here, and the answer is yes. So say for example, we have 650 degrees. This angle exists and we can draw it. So how are we going to draw this one? So remember or recall that one full rotation or one revolution is equal to 360 degrees. If an angle exceeds 360 degrees, therefore, it passed one full rotation. So we need to identify how many rotation happened in 650 degrees. And how will we know the number of rotations? We simply need to divide the angle by 360 degrees. So we need to know the number of rotations done or made given an angle, and that is through the formula theta divided by 360 degrees. Then we get the whole number. So let's try to substitute 650 degrees, divide it to 360 degrees, which is one full rotation. If you use your calculators and divide 650 divided by 360, the result will be approximately 1.81. So the whole number in the quotient that you are going to obtain will be the number of rotation. So the whole number will dictate the number of rotation. So basically, we will be having one full rotation. So starting from the initial side here, we're going to move one full rotation, and this is 360 degrees. This is 0, 90, 180, 270, then back to 360 degrees. So this is already one full rotation, how much angle do we need more to obtain 650 degrees? And definitely, we will know that by subtracting 650 with 360 degrees. So that will be, let's write here, 650 minus 360. The result is 290 degrees. Now, we already rotated 360 degrees. We need to just add more 290 degrees. So this is already 360 degrees. 290 is a reflex angle. So if this is 90, 180, 270, 290 will be somewhere here. So this is one full rotation. Let's add 290 degrees more. This is 90, 180, 270. 290 will be somewhere here. Again, just an estimate. So this now, the rotation or the arrowheads here will denote that we had more than a revolution because we added 290 degrees more. Then, let's of course draw the arrowhead. And this is our terminal side. The terminal side now lies on the fourth quadrant. And this theta or angle that we are referring through these illustrations and symbols is 650 degrees. Another example, let's have a negative angle exceeding 360 degrees, which is negative 1540. Another strategy we can do is to divide this one by 360 and the remainder will be the angle that you're going to draw. So we have here 1540. Let's disregard first the sign because we will just first divide. Divided by one full rotation, which is 360. So if we divide 1540 with 360, we are going to get a whole number of 4. Then multiply 4 by 360. We're going to get 1440. Then subtract 1540 minus 1440. The answer is 100. So the answer here, when we divide 1540 by 360 is 4. Remainder 100. So the whole number will be the number of rotations and the remainder would be the remaining angle that you're going to draw. That's why it's called a remainder. So since this time it's negative 0 degrees is here, negative 90 is here, negative 180 is here, negative 270 until it goes back to the positive x-axis, which will denote negative 360 degrees. Notice that when we divided 1540 by 360, the whole number we obtain is 4. And that whole number will pertain to the number of rotations. So we are going to have 4 revolutions starting from the initial side, which is here on the positive x-axis. So let's draw 4 revolutions. So starting from here, clockwise movement, going back to the positive x-axis. That is one full rotation or one revolution. Another one, that is 1, 2, another 1, 3, and lastly, 4 revolutions. So since the whole number is 4, we also rotated full 4 times. Then the remaining angle or the remainder is 100 degrees. Therefore, from back to the positive x-axis, we're going to plot negative 100 degrees. Take note that we are still talking about negative angles. That's why all of our movements will be clockwise. So from the positive x-axis, negative 100 degrees will be somewhere here on the third quadrant because this is negative 90 degrees. Let's add negative 10 degrees more. Then just an estimate, the terminal side will now be here on the third quadrant. So this theta representing these rotations and the terminal side will be denoted as negative 1540 degrees. Then let me just label that this is our terminal side. Let's now have another positive angle exceeding 360 degrees. So again, just like the strategy we did a while ago, we can simply divide 3621 by 360 degrees because obviously it goes beyond one full rotation. So let's divide 3621 divided by 360. The result is, this is 1, then 360, subtract, we get 21, this is 0, then 0, we'll get 21. This will be our remainder. So the answer when we divide 3621 by 360 is 10 remainder 21. Therefore, this will pertain to number of full rotation, and this one is the remaining angle to be graphed. So since this is now a positive angle, the rotation will now be performed counterclockwise. This is 0 degrees, 90, 180, 270, and back to 360 degrees. Take note that we are going to have 10 full rotations to plot 3,600 degrees, then graph again later on 21 degrees, which is the remaining angle. So it's a counterclockwise movement. Let's rotate 10 times. So 1, 2, 3, 4, 5, 6, 7, last 3, 8, okay, 8, last 2, 9, and last one, 10. This is the last one. I need to go back to the positive x-axis. Okay, so we just had 10 full rotations, equivalent to 3,600 degrees. Now, there's still a remainder, 21 degrees, so we need to plot 21 degrees, which is an acute angle, and obviously will be found on the first quadrant. So this is 10 full rotations. We need to plot 21 more degrees. This is an estimate. So the terminal side may lie somewhere here. This is our terminal side. And this is now the graph of 3,621 degrees. Now to summarize everything that we have discussed about angles, in illustrating an angle in standard position, it is important to draw a symbol that denotes the rotation of the terminal side. An arrowhead must always be at the terminal side of an angle. It also dictates the direction that we are having in drawing the terminal side. Next, a positive angle follows a counterclockwise rotation in drawing the terminal side, whereas a negative angle follows a clockwise rotation in drawing the terminal side. Lastly, an angle in standard position may have a measurement of more than one revolution in any direction, clockwise or counterclockwise, just like what we had on the previous example. And that is all for this video. I hope the learning objectives were already achieved. See you on the next one. Goodbye!